In this video, we're looking at systems of linear inequalities. So we're looking to graph linear inequalities in two variables. And we have our 5 steps in order to do that. The first one is to put the equation into y equals mx plus b form so we can read the slope and y-intercept. These two equations are already there. They're solved and put into y equals mx plus b. So now I can plot the y-intercept and the slope that I'll do for the first equation. And because it's less than, it means it'll be a dashed line instead of a solid line. Now I need to use a test point. 0, 0 is a good one because I need to decide which side to shade. So it looks like I'm going to shade the side that includes 0, 0. And now I'll do the same for the second equation. It's going to be a dashed line. Slope is 1/3. Y-intercept is -1. I can also test 0, 0, and I see that it works. So I want to see the area that both the inequalities have in common, where they both overlap, and it's this purple region. Example 2, I want to graph these inequalities, but first I need to put them in y equals mx plus b form. Note that when we divide by or multiply by negative, we have to flip the sign here. So I find my slope is 1/2 and my y-intercept is -2. It's going to be a dashed line. My test point, I can use a 0, 0. I'm going to check to see if it works, and it does. So I'm going to put little arrows indicating the side that I will shade. The second one, I also need to solve for y to indicate my slope and y-intercept. It's also going to be, this time it's going to be a solid line. I could use the same test point, and I want to shade the region where both inequalities overlap, so it's this purple region again. Example 3, graph the system of inequalities. This time we have 4 inequalities. The first one's going to be a horizontal boundary, an x equals 6 equation is going to be a vertical line. The second one's going to be horizontal, y is greater than -7. I've indicated with arrows the areas that we will shade. The second 2 equations are already solved for y, so I can just read the slope and y-intercept and plot them. And my test point indicates I'm going to be shading down on the purple equation. For my green equation, it's going to be a dashed line. My slope is 8/3 and my y-intercept is 1. I can also use 0, 0 as the test point, and we'll see that it does work. 0 is less than 1. So the region that overlaps with all 4 of these is right in the center. So I'm going to shade that, and I get a quadrilateral shape. Example 4, determine the linear inequalities based on the given graph. So I have 4 lines here. 2 of them are vertical, so it's going to be an x is less than or greater than inequality. The second 2 that I have here, one is going to be a negative slope and one's going to be a positive slope. So I can find the y-intercept for both. And I always want to check a test point to make sure that I've got the inequality written correctly. So in this case I do, and I get all 4 linear inequalities. Okay, so I hope that makes sense to you all. See you next time.